Okay, so we're going to be going over a multi-particle static equilibrium problem. All right, so the problem reads 100 Newton weight W is supported by cable ABCD. There's a frictionless pulley at B, and the hook is firmly attached to the cable at point C. Okay, what is the magnitude and direction of the force P required to hold the system in the position shown? Okay, so first we have to understand our givens, right? We have our first given here. This W is equal to 100 newtons. We have a frictionless pulley here at B, right? You have to consider that's frictionless pulley. And it says that firmly attached at hook C. So we have a hook condition here at C. Okay, so we have, those are our givens. Let's just leave it here, 100 newtons. Okay. Now we can get started. So we have our givens, and let's get started. The other givens that are going to be important for this problem is our dimensions here. We have 40, 20, 80, etc. Those are going to be important for solving our problem. Okay, so let's start by drawing our free diagram for point B. Let's go here. Free diagram for free body diagram for point B. Let's get started on that. So let's have our little graph here. And again, this is for point B. I'm going to put it point B. Okay, so we have our point B here. Let's assume that on our free body diagram, let's assume all the forces are pulling on the point B. For example, we have our force from AC here. We're going to call it force A. Force A. Just call it force A like this. And then we also have this force P, right? Force P here. We don't know what direction it's going, so we're just going to put an arbitrary location. We don't know the theta of this, and we don't know the magnitude. So we don't know the theta, right? That's what we're trying to find. We're going to try to find this theta here because if you look at our question is, what is the magnitude and direction of force P? So that's going to be part of our answer. This right here, it's question. We don't know what that is. So for now, we just put an arbitrary here. Arbitrary magnitude and direction P. This is looking too messy. Let's make it look neater here. Force A here. And an arbitrary force P. Okay, so we can start writing our equations for this at point B. Point B. This is this. Okay. All right. So let's start with some of the forces in the y direction. Some of the forces in the y direction. Okay, so before we do that, we got to find our angle here. This angle right here. Let's call it angle alpha. Call it angle alpha, right? So how do we find this angle alpha? We could just draw a little triangle. So this is 40 and 20, right? So we imagine we have a triangle here, and we 20 is this one, 20 centimeters, and 40 centimeters in this one. So imagine we have this. This is this right here, 20. That's where I got this from. And here, have 40, right? So we're trying to find our angles. This angle right here, call it angle alpha. Then this is going to be equal to tan inverse of 20 over 40. This, just a little quick reminder, this 20 is the rise. In this case, this one, the rise. And the 40 is the run, right? So tan inverse of 20 over 40. So we do our little math. that angle is going to give us 26.6 degrees. So now we have our little angle here, which is 26.6 degrees. Now, imagine we have an orthogonal regular graph here. So this is 90 degrees, right? Because it's a right angle, plus a 26 from here. And that angle is going to give us 116. 90 degrees, 116 degrees. So that means that here, this angle from here to here is 116 degrees. Understood? I'm going to erase this for now because, so this little side note that I did is pretty much just basic geometry here, or I'm sorry, I should say trigonometry. And I just wanted to show you guys how I found that degree, but I think we can get rid of it, or I'm gonna leave it for now. Yeah, let's just leave it. Okay. So now we have, oh yeah, I forgot to add this force right here, which is here. This one, the force from C, this one right here. So we can just call it force C. Force C. And then now we got to find this angle right here. So in a similar way, we don't need this anymore. In a similar way right here, we're gonna find this angle C. So we look at a little diagram here. We have a triangle like this. We have our force C acting here. And we see that this distance here, 50 minus 40. Do you guys see why that is? Like if we look at here, 40 goes to here. So 50 minus 40, that gives us 10 centimeters. And then if we look at, that gives us a rise here, this one right here. 50 minus the 40 gives us 10. And then our rise is this 80, right? You guys see what I'm doing? 10 centimeters and then 80 centimeters. So that's 80. And similarly, we can do rise over run. So tan inverse of we as actually negative 10 because it's down, right? Negative 10 over 80. And that's going to give us, give me a second. That right there is going to give us minus 7 degrees. If we're going this way, right? This is minus in the negative direction. Or if we go in the counterclock direction, that is equal to 353 degrees, which is what I'm going to use for this problem, just to be consistent in all of our just to be consistent in all of our problem. Here. And basically starting from here, it's going to be 90 degrees, 180 degrees, 270 degrees, and 353 degrees right here. Do you guys see? So this 353 is this from here. So we can add that to our little diagram. So this from here all the way to here. From here all the way to here. That's going to give us 353 degrees. 353 degrees. Okay, so now we can continue with, now we can do our sum of the forces equations. So sum of the forces in the y here, this is going to equal, okay, let's start with A, vector A, right? A times, we're doing the force in the y direction, sine of 116 degrees plus, now we look at the force P. Actually, let's look at force C better. We have this force P, but we'll take care of it later, right there. So we have C sine of 353 degrees, and then plus P sine theta. We don't know what theta is. We're just assuming this, whatever from here to here, that's going to be theta. So imagine we have P here. It's getting a little bit messy, so I'm going to put it here. This is P. From here to here, whatever theta is, it doesn't matter what it is. We're going to find out. This is one of our unknowns, is theta there. Now let's do some of the forces in the y direction. I'm sorry, in the x direction. And now we're going to do, for this free body diagram at point B, we're going to do A, now we do the cosines. A cosine of 116 degrees plus C cosine of 353 degrees. And then finally the P plus P cosine of theta. Okay, so now we have our first equation. This is again for point B. For point B right here. Okay, so we have a system now of 1A, 2C, 3P, and 4 theta. We have a system of 2 equations and 4 unknowns. So let's move on to our point B. Or actually, since we're already here, there's an important key to this problem. So there's a little trick that I should have told you guys in the beginning maybe. When you have a tension, when you have a cable rope, when you have a cable wrapped around the pulley here, around this pulley, then that means that this force on this pulley is equal to this force on this pulley, same magnitude. So that's going to be key to this problem. So if we call this our force C in this case, and we call this our force A, then A is going to be equal to C. A equal to C. Again, this only happens when you have a pulley, a frictionless pulley here. This is the trick. When you have a frictionless pulley, and then the force in the cable is going to be the same. That's why we can set them A equal to C. This one right here equal to C because we have a frictionless pulley. I want to repeat that. It won't work in this case right here where we have the hook, the fixed hook, because it's not a frictionless pulley. So then right here we can't assume that this force and this force are going to be equal. We cannot assume that, not in this case, because again, the hook right there. Okay. Now let's go ahead and draw our free body diagram for this one, point C. I'm gonna go ahead and copy this so you guys can, so we can continue this. Let me see how I can do this. We're going to continue with our free body diagram of point C. Okay, so we already have, again, point B diagram, free body diagram, the equation, we have them here. Free body diagram here. Now we're going to do one for point C. Okay. So point C here, we have our graph. Point C. Let's put her here, here. Point C here. That's our point C. Now let's talk about forces here. This one, we're going to call it force D. And this one, we're going to call it force. This one right here, we're going to call it force C because it's the same force. You see why? Because it's the same force. This is the same. This one here is equal to this one here. We're going to call it the same force C. So that means that this force right here is going to be equal to this, and it's going to be equal to this. Again, this is because of this right here, because of the friction is putty. Okay. So now we have, oh yeah, and we got to add the weight. The weight, which is 100 newtons. Right? And then we can do our sum of the force in the y direction. So we know this is 50 right here and 50 here. So if we do our little triangle, we have here for this right here, we have this angle at 50 and 50. If we do tan inverse of 1, you're going to see that it's 45 degrees. 45 degrees. So we know this right here is 45 degrees. And then if we look back at our equation from here, we got this equal to be 7 degrees, right? You guys remember from here? Where is it? We found this to be 7 degrees here. You guys remember? Here, negative 7 degrees. So we know that this right here, it's going to equal 7 degrees, right? So we have this one equal to 45 degrees. 45 degrees. And then from here to here, it's 180 minus 7, which is 173 degrees. 173 degrees. Okay. Now we can do our sum of the force in the y direction. Sum of the forces in the y direction, it's going to equal, let's start with C, just because it's this is alphabetical order. So C sine of 173 degrees plus D sine of 45 degrees. All of this is going to equal 100. This doesn't fit. Doesn't look good. Let's do it here. Fy, sum of the forces in the y is going to equal C sine 173 plus D sine of 45 degrees minus 100, right? Because this is the force acting down 100, minus 100 newtons equal to 0, right? Because remember, some of the forces in each direction have to be equal to 0. Now let's do some of the forces in the x direction. In this case, we have C cosine 173. Again, this is all in degrees, plus D cosine 45 degrees. This is for D right here, that vector. And then we don't have any other forces in the x direction, so we can put these equal to 0. And now we have a system of 2 equations and 2 unknowns. So if we solve for this, you guys can pause the video and try solving it for yourself, but I've already done it. And I don't want to spend the time going over it again. So I'm going to put the solution here, which is C. Basically, what this is, what this is a system of 2 equations and 2 unknowns. So you guys can go ahead and look up another video on how to do that, or just, you guys may already know how to do that, but if you don't, you guys have to review your algebra because it's important for this. You can't do it without it, unless you use like a calculator or a system solver or something. Okay, so basically, when we do the math, C equals Okay, so once we figure out for the system of equations, we see that C equals 90 newtons, and D equals 125, or let's say 126 newtons to round up. So now we have magnitudes and directions of each of these force vectors. Now let's go back to the question. Okay, what is the magnitude and direction of P? So what we're trying to do here is try and find magnitude and direction of P. So we haven't found that. So far, what we've done is we found the magnitude of D, which is this one right here, and C, which is this one. Now we can go back to our system of equations that we got from point B in the first part of our problem, and we can try solving for that. Okay, let's go ahead and copy this. All right, we can put it here. Okay, I'm gonna hide this. Okay, so now we can plug in for C and A. Okay, so we have to remember what we talked about earlier. Then A equals C for this type of problem when you have a frictionless pulley here. So everywhere we have an A, we can substitute for a C. So in reality, we could just call this C. We could get rid of this and call it C. Remember, because A equals C. That's what we learned from our A equals C because of this right here. So we can call it C. And now we have a constant 90C, right? Right here, that we just figured out. C equals 90. Okay, so we can solve for this. 90 sine 116 degrees plus 90 sine 353 degrees equals negative P sine theta. And then for this one, we can say 90 cosine of 116 degrees plus 90 cosine 353 degrees equals minus P cosine theta. This should be equal to 0, okay? Just forgot to do it in my other one, but yeah, this right here, it's equal to 0. And that's how we get these equations. And now you can tell that we have a system basically of 2 equations and 2 unknowns. Do you guys want me to solve this? Let me try solving it real quick. So if you guys plug all this into a calculator, you're gonna get pretty much negative 69. I'm sorry, no negative, just 69. And then that's going to be equal to negative P sine theta. All I did was input all this right here into a calculator. And that gave me 69, right? So now we got to do this one. And for the second equation, if you input all that into calculator, you're going to get 50 and then equals to minus P cosine theta. So this 50 I got from here. Plugged all this right here into a calculator. That's all I did. And that's how I got the 50. Okay, so we can try solve. Now we have a very simple equation, and we can try solving for that. So let's set for this one, let's set P equal to minus 69 over sine theta, right? Sine theta. Now we could use this to plug into here. So if we plug it in here, we're gonna get minus times a minus is gonna be 69. Negative times a negative equals a positive, so 69. We're gonna plug it here. That's all I'm doing. So we're gonna get 69 cosine theta over sine theta. It's gonna equal 50. And then furthermore, if we simplify, we can say sine theta over cosine theta equal to 69 over 50. And if you guys don't remember, sine over cosine is going to give us tangent theta. So tan theta, it's going to equal 69 over 50. And then we can use the tan inverse equation, tan inverse of 69 over 50. And that is going to give us a degree, which is equal to 54 degrees. 54 degrees. So once we have this 54 degrees, the theta equal to 54 degrees, then we can go ahead and plug it back into one of these equations right here. So I'm just going to use the 50 one. So 50 equals minus, I'm pretty much using this equation, right? 50 equals minus, but you could use this one too if you like, there's no problem. 50 minus P, still we don't know what P is still, cosine theta. Well, now we know our theta, so we're going to input it cosine of 54 degrees. And then we can try solving for P, which is 50 divided by cosine of 54 degrees. And that is going to give us, we could just put the negative here, P. So P equals negative 50 cosine of 54 degrees. Okay, so after solving this for P, we see we get that P equals to pretty much this right here. I used a calculator, and that equals minus 85 newtons, right? So that's our P. So now we've solved for everything. 85 P. P equals 85 newtons, and it's acting at an angle, again, from our little equation right here, 54 degrees. So now we figured out the magnitude and direction of our force P, which is what the question was asking for. I don't know if you guys remember here that the question was asking force and magnitude. I want you guys to consider something though. I want you to pay attention to this, please. The negative 85 newtons. What does that mean? So right here, we have our particle B, right? And then if we look back at our original free body diagram, we assume the direction of this was this way, correct? But it doesn't, at the end of the day, it doesn't matter what we assume because the math is going to work out. So what this is telling us, our answer is telling us here, 85, negative 85 newtons. That means that, okay, imagine we have 54 degrees. So this, we know this is 45 degrees. 45 degrees, right? Right across the middle. So 54 degrees will put us somewhere here. This is 54 degrees here. You see? 54 degrees. But this is not right because this vector here on point B, imagine this was particle B. This one, right? This would represent 54 degrees with a P equal to 85, positive 85. But I want you guys to understand that, look at our answer. You see, guys, see what our answer gave us? Our answer was P equal to negative 85. So what does that mean? It means that this is not acting this way. No. This would be P equals 85 degrees, but P equals negative 85. It's the opposite of this. Okay? So this, in reality, is our answer. 85 degrees here. So assuming this right here is 54 degrees. And we could use the alternate interior angle theorem. So this is 54 degrees here. We know because this side, this angle right here must be equal to this side from geometry. And then this, in reality, this is what this represents. Because again, it's going to negative. Positive would be this way. But negative, because we have the negative here, it means that this is what it actually means. Okay? So our force P, our P magnitude and direction is as follows. You can say P equals negative 85 newtons at an angle of 54, with an angle of 54 degrees. And that is our answer. I just wanted you guys to understand what the negative meant, what the negative sign meant in our I want you guys to really understand what the negative sign really meant here. That it means that it's, because if not, you guys are going to get lost maybe. I want you to understand that it's not pointing this way because it would be a positive, right? This is 54. It's going actually this way. So this is the representation of P, of vector P. And that solves our problem. P equals 95 newtons with an angle of 54 degrees. I'm sorry, negative 85 newtons with an angle of 54 degrees. And that is how you solve that problem. Hope you guys enjoyed the video. Let me know if you guys have any questions or comments. I'd like to improve my videos so you guys can better, so I can help you better understand these subjects. Thank you guys.